Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R Software. So you can recall that in the last lecture we had started a discussion on univariate graphics and plots, and we had considered the bar plot. So as we had discussed, this bar plot is constructed when the data is categorical or attribute, and it represents the absolute frequencies or the relative frequencies on the y-axis and different categories on the x-axis. Now, this bar plot can be extended in many ways depending on the nature of data. If data has different types of layers, then it can be extended to different types of bar plots. So today I am going to talk about one such extension, which is subdivided bar plot. And later on you will see I will come back again to this bar plot when I will show you how to use the ggplot2 package to create such bar plots and different versions or different varieties of the bar plots. And the next aspect I would try to take here is about the pie diagrams. As I told you that my objective is that initially I want to take up some topics which with which you are familiar, like as bar diagram, I know you are familiar, pie diagrams, you are also familiar. So if you try to create such diagrams, you will get more confidence. So I will try to take the same examples which I took in the last lecture, and with some more examples, you can see that how we are working on the same set of data in different ways for different types of graphics. So let us begin this lecture, and we try to understand how we can create a subdivided bar plot and pie diagram. So first we try to consider here the aspect of subdivided or component bar diagram. So this is also a bar diagram, and such subdivided or say component bar diagram, they are created for categorical data or the attribute data, and it divides the total magnitude of variables into various parts. If the data has some type of subdivision within the categories, then actually this type of graphical device or this type of graphics is more useful in representing the data. So in order to explain you this subdivided or say component bar diagram, let me try to take here an example by which I can very easily explain you that under what type of circumstances this type of graphic can be created, right? So suppose we have some data on the number of customers who are visiting the 3 shops during the time period of 10 to 11 a.m. on 4 consecutive days. So the data is like this, that there are 3 shops here, 1, 2 and 3, and on day 1 the shop 1 has 2 customers, shop 2 has 20 customers, and shop 3 has 30 customers, right? And similarly on the day 2, shop 1 has 26 customers, shop 2 has 53, and shop number 3 has 40 customers. Similarly, on day 3, we have 42, 15 and 25 customers in shop 1, 2, 3, and day 4, we have 30, 75 and 100 customers who visited the shop 1, 2 and 3. Now, we want to create here a plot which can reflect this type of information, right? If you try to create a simple bar plot, then we have 2 options. One option is this: I can create the bar plot here for like this: shops 1, 2 and 3, or second option is this: I can create here for this days, day 1, 2, 3, 4 days. But none of the graphics will be able to give us the information about the number of customers who visited the particular shop on a particular day, because actually this is changing, right? So in order to create this type of graphic or to represent this type of data, subdivided or say component bar diagram help us. But the requirement for the creation of such diagram is that the data has to be given in the form of matrix. Now you can recall that in the beginning of the course we have discussed about how to enter the data in a matrix format. There I told you that we will be using this concept. So now you can see here how the data here looks like. So if you try to look at this data, so this is here row 1, row 2, row 3, row 4, and you have here column 1, column 2, and here column 3, right. So that means this data can be represented in a matrix of order 4 by 3. So what I try to do here, I try to give here a command matrix with n row equal to 4, n column is equal to 3, and the data, in case if I want to enter it row wise, so I have to write down here by row is equal to true, and then I have to give here the data like as 2, then 20, and then 30, and so on here like this, right. So you will get here this matrix like this one, and you can see this matrix is the same like this data, right. Now after this it is very easy. You simply have to use the command bar plot, and the data has to be given in the matrix format, and this will create a subdivided or component bar diagrams with columns of the matrix as bar, and section inside the bar will indicate the values of the frequency in cumulative form. So how does it interpret? So let me try to show you these things, and then he will try to understand it, right. So if you try to see, if you use this command on R software bar plot cust, so the data will, this graphic will look like this for this data. Now if you try to see, there is bar number 1, bar number 2, and bar number 3, and these bars are actually subdivided. You can see here there are different shades of actually gray, right. Yeah, I will show you that you can change this color, but first let us try to understand with the default values how to interpret this graph. So if you try to look at the data of shop number 1, and if I ask you, can you find here the cumulative frequencies? So for this shop number 1, on the day 1, the cumulative frequency will be 2. On the day 2, the cumulative frequency will be 26 plus 2. On the day 3, the cumulative frequency will be 42 plus 26 plus 2. And on the 4th day, the cumulative frequency will be 30 plus 42 plus 26 plus here 2. So actually these cumulative frequencies are plotted over here. So if you try to look here, this is here actually shop 1, shop 2, and this is here shop 3. So if you try to see, look at the first this line which is here, which is this color, darkest gray color. So this is indicating here actually the value 2. Now after this, if you come to the second line which is here, this is indicating the value here 26 plus 2, which is 28. This is actually the second cumulative or the cumulative frequency of day 2. Similarly, if you try to look at the third line is representing the cumulative frequency of day 3. Right. So you can see here the cumulative frequency of day 3 is 2 plus 26 plus 42 equal to 70, which is here. And finally, the fourth line here, this is indicating the cumulative frequency of the day 4, that is the total frequency of day 1, 2, 3 and 4, which is 2 plus 26 plus 42 plus 30 equal to 100. Right. And the same interpretation goes for the second and third bars also. So here you can see you have an advantage that it's not only shops, you can also consider or you can compare or you can have the information that how many people visited to these shops on particular days, and by considering the subdivisions you can get this information very clearly. For example, if I try to show you here, suppose if you try to look at this lightest gray part in the 3 bars. So you can see here in the shop number 3 bar, this is the largest, then it is the shop 2, and then it is the shop 1. So it is indicating that in shop 3 there were maximum customers, whereas in shop 1 there were minimum customer, which is indicated by the light gray color, right, on the 4th day. And you can see here, this is the same thing here on the day 4, this shop 1, shop 2, shop 3 had 30, 75 and 100 customers, right. So this is the advantage of subdivided or say component bar diagram. And now in this bar diagram, if you want to make it more informative or if you want to give different type of information, you can give. And now you will see one thing here, that I will try to give this information, but in most of the cases you will see that the same or similar commands will be used, right. For example, if I say, if I want to give here the names here, shop 1, shop 2, shop 3, then they are given by the same command which we use in the earlier lecture, names.arg. And I am writing the same style, that using the command C, shop 1, shop 2, shop 3 within double quotes, I am writing inside the parenthesis. And then if I want to write down here on the x-axis, this here shops, then I have the same command here, xlab, and which is inside the double brackets, I am writing here shops. And similarly, if I want to write down here days, so days is given on the y-axis, so this is here ylab is equal to days. And similarly, if I want to change the color so that I can understand it easily, so I am using here the command col, red, green, orange, brown, and you can see here this red, green, orange and brown, this is the same color which has come. So you can control all other parameters of the graphic also, so that you can get here better outcome, right. So let me try to first show you this graphic, that how you can create them on the R console. So let me try to first create this data on customer. So you can see here, this is the data on customer, and if you try to say here bar plot of customer, CUST, you can see here this type of graphic is coming. Now, in case if you want to make it more informative and you want to give it more information according to your requirement, like as titles on the x-axis, y-axis, colors, etc., then you can see here the same graph is chosen, prepared like this. Yes, you can very easily also control here the frequencies limits on the y-axis without any problem, right. So you can see here it's not a very difficult thing to do. Right. Now, let me try to give you here idea about pie chart. So, pie charts are similar to your bar diagram. They are also used to represent the categorical data. So, that means if you have a attribute variable or categorical variable, then the data is going to be compiled in the form of frequency table indicating the absolute or say relative frequency, and these absolute and frequencies are represented in the pie chart. But instead of having here a bar, we are using here a circle, and the circle is partitioned into segments, and every segment represents a category. So instead of having here bars as in the bar plot to represent the category, we have here the segments of circle to represent the category. And the size of this segment depend on the relative frequency. And such size is actually determined by the angle, like as relative frequency into 360 degrees. So you need not to do such calculation, but this our software will do such calculation to give you the details. So in order to create the pie diagram here, you have the command here pie, P-I-E, right? And yeah, that is the something like X where you have to give the frequencies data. So instead of using the X raw data in the X data vector, you have to use the table command. This is what you have to keep in mind. And then you can give here the labels to give different types of names to different segments. And then there are other options like as radius, main, color, clockwise, whether you want to have the sequence of the categories clockwise or say anti-clockwise. So labels will give you the description of the slides. Radius will indicate the radius of the circle of the pie chart. Main will give the title of the chart that you remember. In the bar plot also we use the same command. COL will give you the colors to the slices, and you can recall that in the bar plot also we have used the same command. and clockwise is equal to true or false, that's a logical variable. It will give you the option that if the slices are drawn clockwise or say anti-clockwise. So if you use clockwise is equal to false, then that is actually the default, then the slices will be plotted clockwise, and if true, then anti-clockwise. So let us try to take here the same data what we took in the case of bar plot, and we try to create here the pie diagram. So I'm trying to take most of the time the same data set so that you don't get confused, because this example now is in your mind. So it will be easier for you also to understand that how the same information can be represented in different ways and how the interpretations can be drawn, right? So this is the same data where we have recorded the qualifications of 10 persons as graduate indicated by G, and non-graduate as indicated by N, and these graduate and non-graduate are indicated by the numbers 1 and 2. So we have this graduate non-graduate data and then 1, 2 here. So graduate is represented by 1, non-graduate is represented by 2, and we store this data in the data vector here quali, like quickest one. Now after this, if I use the pie command over quali, then you get here this type of graphic. Do you really want this thing? So once again, I would like to have your attention that in some software you need to give the data directly, but in our software you have to give the frequency data which is obtained by table command. So it is now indicating you the entire data set. You have 10 values, so it is indicating the 10 values, but you don't want this. But what do you want? You want the pie diagram of the table command. So I try to obtain the absolute frequency using the table quali command, and then it is something like we have two categories 1 and 2, one has frequency 7, 2 has frequency 3, and then I try to use the command here pi inside parenthesis table quali. So now you can see here this angle is actually indicating the proportion of the relative proportion of the frequency. So essentially this is indicating the relative frequency, right? And these are here two segments. This is your here segment 1 and this is your here segment 2, right? So now different type of information can be embedded into the graph, so that these graphs can be made more informative. How? Suppose if I want to give here the labels like as here graduate and here non-graduate, so that it is easier to understand that which of the segment is representing what. So for that I can use here the command labels inside the pi command, and I can give the graduate or non-graduate words which I want to print on the graph in these categories in double quotes, and these categories have to be given in the format of a data vector. Similarly, if you want to have here a title like as persons with qualification, then you need to have use the command here main, and you write the title within the double quotes persons with qualification, and this will come here. And similarly, if you want to use here the different colors for different sequence, so in the same sequence you give those colors and use the option COL, and then you combine them by data vector as say red and blue written inside the double quotes, and then you can see here that these colors are changed. Segment 1 is red and segment 2 is here blue. So you can see here it is not so difficult to operate it. But okay, let me try to show you here first these things on the R console, and then I will try to take here one more example to convince you that it is very easy to create pie diagram in this one. So okay, so let me try to clear the screen and let me try to have here the data on say here quali, and then you can see here. Then after that, if you try to, I will show you, if I try to simply use here pi over quali, you will get here this 10 categories. But if you try to make it here for the frequency, then you have to give it here table command, right? And then you can see here now there are here 2 categories only. And if you want to make it here more informative, then I can give you here this type of options like as label, main, color, and you will see that it is not difficult to create such informative pie diagrams in the R software, right. So now let me try to take here the same example that I took in the case of bar plot, that there are 3 salespersons in a shop which are indicated by 1, 2 and 3, and there are 100 customers who visited the shop, and we have recorded the data that which customer was handled by which of the salesperson. So for example, if I say here 1 here, that is indicating the first and second customers, they were handled by salesperson number 1, the third customer was entertained by salesperson number 2, and so on. And this data is now stored here as a in the data vector sales per. Now I want to create here the pie diagram. So I can create here the frequency table using the command table over sales per, and it comes out to be like this, that category 1 has 28, means the 28 absolute frequency, category 2 has 43, and category 3 has 29 absolute frequency, which means the salesperson number 1 attended 28 customers, salesperson 2 attended 43 customers, and salesperson 3 attended 29 customers, right. And if you try to make it here this pie diagram, you can see here it will come like this. So this is indicating category 1, category 2, and here category 3, and the choice of the colors is automated. It was given by the default option given inside the pie command, but you can change them very easily. For example, if I want to give here the labels like here salesperson 1, salesperson 2, and salesperson 3, then I can use here the command here labels, right, as we did earlier. And if you want to make it here title like salesperson attending customer, then I can use the command here main and give this title. And similarly, if I want to change the colors of the segment, I can use here the command C, and then I can make it here green, red, and blue. So the 3 segments will be prepared according to that thing only, right. So let me try to show you these things on the R console, and exactly on the same way as I did in the last lecture, that I took the example of painters, that I will to create the bar diagram. Similarly, I will try to create the pie diagram here also, right. So I can clear the screen. So you can see here this is your data on the salesperson, and now I try to create here directly there this pie diagram over this frequencies. So you can see here that it is happening here like this. And similarly, if you want to use here this thing where you want to give colors, labels, headings, etc. So you can use here this command, and it will come out to be here like this, right. So you can see here it's not actually difficult, and here you can see that these angles here are indicating the relative frequency. So you can see here that the red color segment has the maximum angle over here. So this is indicating that the salesperson number 2 has attended the maximum number of customers. And you can write these numbers also here. There are various options available, but I will leave it to you only. So now let me try to take one more example to show you that how, without looking into the data, you can create such pie diagrams without any problem. So for that, I will use here the data set painters, which is inside the mass library, and you already have used it several times. So I load my library by using the command library mass. Then out of those, there were 5 variables which can be obtained using the command call names, composition, drawing, color, expression. These are the 4 quantitative variable, and there was one, and actually there is one qualitative variable school, which is here like this, which is trying to give us the idea that that which of the painter has attended which of the school. And its absolute frequency can be obtained by the table command, and its relative frequency can be obtained by using the table command with the variable and divided by the length, right. So these are the absolute frequency that we already have done, but I have just repeated it here so that you feel more comfortable. Now, in case if you try to create the pie diagram for such a data, so you can see here pie, and then inside the parenthesis using the table command, you can use the variable painters $school. So you can see here that this is here the school A, school B, school C, D, E, F, G, and here H. And these angles are representing the the relative frequency. So you can see the angles of this here A and D, which are indicating that okay, they are almost they are the same, and so same number of painters have attended the schools A and D, and this is the maximum number. And similarly, you can look for other options also. And for example, if you try to see this E and G, by looking only at this actually curve E, G and actually B also, you can see here that they have almost the same relative frequency. Yeah, sometimes these segments may be very close to each other, and it may be difficult for you to visually be confident that the relative frequency are exactly the same. But in such cases, you have to use the frequency table. But this graphical view will give you a fair idea about the magnitude of relative frequency. And that is what exactly I told you in the beginning when we started the course, that or this lecture on this graphic, that we always have to use the analytical tools and the graphical tools together so that you can have a more reliable and clear information, right? So, and similarly in this pie diagram, if you want to make it more informative, then I can use here the title on this graphic as School of Painters in Mass using the command main, and then I can use here the school's name here as A, B, C, D, etc. Well, I have given A, B, C, D. You can choose something else also. So I can use the option here names.arg. Then if I want to have the title on the x-axis as schools, then I can use here xlab. Title on the y-axis, then I can use here the option ylab. Whatever title I want to give, I have to simply type it inside the double quotes, right? Then after that, if I want to give the colors to this segment according to my choice, then I have to give it in the same order, say red, green, orange, pink, yellow, blue, gray, sky blue, and you can see here that these are the colors which are happening here, right? In the same order you can see, right? And you can see here, this is this graphics with more clear visibility, right? So let me try to create this graphic on the R software also. So first I need to use here the command here library mass so that I can upload my data. So I can clear the screen. Right, and then I simply have to give here this pie. So you can see this is the advantage that without doing anything, you can call any variable without disturbing the database. And you can see here, this is your here pie diagram. And if you want to make it here more informative, you can use different types of option like its color, xlab, ylab, names, etc. And this graph will come out to be here like this, right? So yeah, there are some warning messages that you can see. They are trying to do something, but anyway, so this is the graphic which you have obtained here, right? So now, I stop in this lecture now, and you can see here this was a pretty simple lecture, and this was simply an extension of the last lecture where we have considered the bar diagram and par diagram to represent the data from the categorical or say attribute variables. So as I shown you that it is more important for you to understand how the data has to be represented and what type of information do you need. For example, the bar plot I used earlier just to indicate the data in the categories. But if there is more information which is contained inside the categories, for example, in the first example within shop 1, there can be different number of customers on different days. That is additional information. So instead of using the bar plot, you can use the subdivided bar plot. And the more important part is it is not difficult to create. You simply have to enter the data in the way which R requires. And then it will give you the information which you wanted to dig out from the data. So that is what I was emphasizing again and again, that it is very important for you to understand what actually R wants and what type of data is given. So you can see here I have given the data in the data vector format or in the matrix format in the same command. And it is giving you two different type of graphics. The next important aspect what you have to understand is how to interpret it. For example, in the bar plot, you just looked on the height of the bars. In the subdivided bar plot, you looked on the cumulative frequencies as well as their frequencies, which are obtained as a difference of the two absolute frequencies in the two groups. And similarly, in the case of pie diagram, the same data was represented, but now the angle was the place where you have to look to understand the magnitude of the data. And there are different options which are available in the R software to control your graphics, to customize your graphic on to make it according to your choice, according to your requirement. This is one of the very strong advantage of using the R software, that you have complete control of your graphic. So my request to you is that now you try to take simple example first and try to make an understanding that how I have to enter the data to answer a particular question, then how the data was entered, and how the graphic is trying to interpret the same data. Try to think about it, try to analyze yourself, try to stabilize in your mind that by looking at the graphic you can very easily understand what is the information being given by the data. It is something like you can see an expert doctor will look on the X-ray, and within very few seconds or minutes, the doctor will correctly diagnose what is happening inside the body. Is there a fracture or not? So similar is the expertise which you people have to develop. By looking at the graphic, you should be able to tell what is happening inside the data. Take a small data set and then try to take a bigger data set and develop more confidence. So you try to practice it, and I will see you in the next lecture. Till then, goodbye.